Hello everyone! This unit will introduce predicates and quantifiers. This will help us start to build more rich types of things that we'll be able to prove. Predicate is a proposition with variables as inputs. Okay, so think of it just kind of as a function whose output is true or false. For example, consider the predicate p of n, which outputs whether the input n is a square. Okay, so I can plug in, for example, p of 4 is equal to true, because 4 is a square, but p of 5 is equal to false. Okay, similarly, I can think of predicates that take multiple inputs. So say p of xy is equal to whether or not x plus 2 is equal to y. So depending different inputs that I plug in, it either is true or false. Okay, and another example, p of xy, is that the evaluation x to the y is irrational. Here are some examples of cases where it's true and where it's false. Okay, so we've seen here that a predicate, in fact, all the examples on the previous slide were sometimes true. You can also have predicates that are always true, or ones that are never true. Okay, so for example, if I look at the predicate p of x, which is equal to whether or not x squared is greater than equal to 0, and I'm talking about real numbers, then this predicate is always true for all real numbers. Okay, in the middle, I can have some other predicate, like this expression here, that's true for some inputs but not for others. Or a predicate that's never true. For example, if I'm talking about real numbers, then x squared will never be less than 0. Okay, so quantifiers are ways of taking these notions of always true, sometimes true, or never true, and translating them into math. Okay, so kind of some of the terminology. If I say something like, for all x, p of x is true, or p of x is true for every x, okay, versus sometimes true, where there exists an x, or for some x it's true, or for at least one x this is true, versus never, where this is not true for any x. Okay? These are going to translate over to two different quantifiers. Okay? The first quantifier, and no, this is not a typo, this is an upside down x, is for all x. Okay? So for example, if I say this upside down a x p of x, this represents for all x p of x. That is, the predicate p is true for all of the values x in the domain. The other one is this backwards e, which is there exists. Okay, so if I see here, I read this as there exists y such that p of y. And this means that the predicate p is true for at least one value of y in this case in the domain. Notationally, there's a few different ways that you can write this. For example, you can do for all x and then with parentheses, or put a period or a comma. All of these are legally okay. I typically try to keep with the first one. It's slightly more formal than the others. But the other ones, you will definitely see them all over the place. They're commonly used, and it's okay as long as there's no confusion. Okay, so this one we're keeping relatively short and sweet, but in the next unit, we'll see some more about quantifiers.